The Google Meet streaming link?
Yeah. That's it. That's it. Yeah, I apologize for this, but we have the technology to do that. You know, what I should have done is I should have told everyone to stay in your room and follow it online. That's what I should have done. I didn't think of that. If this isn't fixed on Friday, you're going to get an email from me. Well, Friday we have tests. So that's done. I had 2 tests in here today, so 2 classes I didn't have to worry about. I did my calculus off the chalkboard. All right, let's see here. In chapter 4, let me see, down here somewhere, Diego let me see here, just see it right here. There's a homework right here. This homework here. And again, you guys can't. You're going to have it on a device to see it. But down here at the bottom, a couple of these answers were slightly off. Like for example, right here, I believe I had an x plus 2. I think it's an x plus 1 right here. It's x plus 1. And then up here somewhere right here, I believe. Well, you know what? Still wrong right here. This would be a log base 5. So it's still a little bit wrong. These are all natural logs. So that is log base 5. I'm going to do that. The internet is absolutely horribly slow right now. Okay. All right. So the answer for B here should be all log base 5. And then down here should be an x plus 1, not an x plus 2 right here. All right. Now you see what I'll be able to do today. I'll be able to circle stuff on the board. Oh, wow. Oh dear, that's going to be terrible. You guys are having a ball. You're loving it. All right. So I'm going to have to guess on the board where these things are, like right here. Oh, no. 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 Incorrecto. Okay. All right. Well, we'll sit to see what happens here. Okay. We go to chapter 5. And we were on this screen. And tell you what I'm going to do. Here's what I'm going to do. If this doesn't work with me writing on a board that I can't see, then I'm just going to dismiss class. I'm going to record something in another classroom maybe, and you'll have to watch it online. Unfortunately, we don't have a lot of class days to mess around with. We can't afford to miss a day is what I'm saying. All right, so let's see. Yeah, so well, that would be interesting, is use a chalkboard and, pardon me?
Tomas is good.
Well, yeah, Tomas would, maybe I can get this camera aimed at the chalkboard. What do you think? I don't know. Yeah, you know what? Here. Okay, Tomas, we're gonna move the the camera. Okay, so you should be looking at the chalkboard. I don't want to share my screen, so I'm gonna stop presenting. Oh, wait a minute here. No, I'm not going to share my screen. That's what. So stop presenting. And I'm going to try to share this camera.
I think you should be able to just pin your camera to his fingers to know it.
All right, let's see if I can figure out how to do that.
No, I think Tomas can pin it. Like, if he puts
Oh, okay.
He can pin it.
Okay, Tomas, can you find a way to get this camera on your screen?
Yeah, it's right there in the middle.
Okay.
I'm just not sure if I will be able to see the whole thing.
Yeah, I'll have to move the camera during the show here.
Oof.
Yeah. All right, so that's looking at the board. All right, here's what we're gonna do. I know. You can't unsee that. I know. That's really bad, really bad. We're gonna move this as far as this cord will go.
This one is near.
I'm sorry, I can't hear you.
This one is near. Now?
I think. No, I want this. And yeah. Okay.
Yeah, that would might be closer to.
Pardon me? Yeah.
Might be a little further if you have it.
Oh, that's true. Unwrap it. And then, where's that looking at now? This is a head trip. Let's go up here. All right. Can't even blame this on COVID. What good is it if you can't blame it on COVID? You can blame everything on COVID. All right, that's what we're going with. That's what we're going with. No board today. We're going to do shock. There we go. And I may have to scoot Eli over. Well, I tell you what. I may have to just. No, you might be all right. I'm gonna be all right. All right, so let's fly here. I'm on, I think, slide number 9.
Yeah.
Okay. And it's on the effective rate.
Yes, sir.
I'm sorry? Oh no, I got it. I got you. I have my secret supply. I don't put the good stuff out.
You can use it then.
Yeah. Yeah. So, there we go. So Thomas should be able to see us. When I go on the chalkboard, I go from right to left because I'm Hebrew. No, because I want to cover myself up. Hey. Christians are the spiritual Israel, it says. Okay, so I feel an affinity to the Hebrews. Okay, so we're going to go this way, and that way I don't write in front of my body doesn't block what I'm writing. So the effective rate, you see the formula there, and it is, see, when you have a compound interest rate, compound interest, you have an interest rate for the whole year, but when you compound, you saw that it amounts to more, okay? But when you compound 12 times per year or 365 times per year, it amounts to an effective interest rate that's larger than the stated annual interest rate. So the effective rate, and it's given by that formula, and I'm going to write the formula up here. RE is 1 plus R over N to the N minus 1. All right. I don't have my calculator over here either. So you're just going to have to trust me on some of these answers. But you have the screens there. So I put some of the screens in the slides. So what effective rate is equivalent to a nominal rate of 6% compounded semi-annually and then compounded monthly? Right? So RE, so part A, the effective rate is going to be, now semi-annually, N equals 2. That's the number of compounding periods per year. All right, and that's up in the definition. So you're going to have 1 plus 0.06 divided by 2 to the second power. I do have 2 colors of chalk. Now, how cool is that? 2 colors of chalk. That's to the 2, and that's the only number that's going to change here next time. So it's going to be then minus 1, and that comes to 0.0609 or 6.09%. All right. I hope Tomas, I don't know if Tomas can read that or not. I hope you can, bro. I really do.
I'm not sure.
You don't know if you can read this up here?
Yeah, the 6.09% is, yeah, but like the one in the parentheses is
Okay.
kinda.
Here, yeah, okay, here. Let's then.
If you can't get close enough, I can probably move my computer and use that camera too.
Oh, that's interesting. The closest possible. Let's see here. Here's what I'll do. I'm gonna do this. Move that over. That gives me more cord. All right. I don't know. Is that, hopefully that's a little better, Tomas, I
Yeah,
hope.
that's better. Yeah, now I can see everything.
Good. Good. All right, where's my? All right, so part B is the same question except for interest compounded monthly. So monthly you have N is 12. So the effective interest rate, 1 plus 0.06 divided by, oh, wait a minute here. Whoa. Divided by 12. I should have put this in. Divided by 12.
How about the first one is 2, no? The A part has to be 2, no?
Oh, yeah, that's right. Yeah, there you go. And then this is to the 12th. Okay. Minus 1. And that comes to 0.061677 or 6.17%. All right. Now, one principle here is that the more frequently you compound, the higher the effective interest rate is. All right. And if I have my calculator here, we could get this up to daily 365, and it would be a little higher. But after a point, it won't go beyond a certain point. It won't keep getting higher and higher and higher and higher if you do it a million times, if you compound a million times. There is a theoretical maximum, and it happens. There's a way to compute it. If I was on my, if I had the calculator, I would do it. But anyway, that slide. We got one slide done. It took us 20 minutes. That's right. That's right. That's right. I appreciate your flexibility, guys. All right, I want to move over a little bit.
I think that is the same time because in that board there are no like the your college event, so we have the same time.
Oh, All right, so now I got to move over a little bit. That way, maybe. Okay. How long will it take for an amount of money to triple at the effective interest rate R? So how long will it take some amount of money? So you don't even need to know how much money. You want to know how long it will take to triple. And, ooh, I didn't bring a calculator. Here, let me, I'm going to use Trevor's calculator here real quick. So watch, this is, our effective, our equation that we're using is S equals P 1 plus R to the N. And now it's saying how long. We're going to make this in years. Right? That's going to be in years. Now, we want to know how long will it take for P, your present amount, to equal 3 times that. So we want to know how long it will take that to equal 3P. N, right? And that is going to be, well, let's see, we can cancel some P's. So you wind up with 3. Now, we need to solve for N, right? Solving, I'm going to do it over here. Solving for N, okay? Because you're told that the effective rate is R, right? So that is how many times per year. So now to solve this for N, how do we get an N? How do we get to N? Well, we take a logarithm. This is where I'm going to need his calculator. Ironically, I just took my calculator downstairs. I had it up there. So you're going to take a log of both sides. And I'm going to choose to do natural log of the left, natural log of the right. Right? So that's natural log of 3. And then this is going to be what? 1 plus R to the N.
Get the N come right down front.
And the N can come down front. You're ahead of me, bro. That's great. So the N will come down here. Right? And so we're going to get natural log of 3 is N times natural log 1 plus R. And so to solve for N equals natural log of 3 divided by natural log of 1 plus R. So you put your interest rate in there, and that's how long it will take to triple. And I did not need the calculator off. Right. Thank you. All right. You got some homework there, that 5.1. So that homework 5.1, let's see, we had the test Friday. So we'll be generous and make it due next Wednesday, although you might have something else to do next Wednesday too. So we're going to put down here homework 5.1. We have that due Wednesday. And next Wednesday is the Friday. Oh, you know what? We can make it do Monday. Friday. Yeah, it needs to be due Monday.
It is 21. 25.
Do Monday. It's 4/21. All right. We have been computing future values. How much will you have in so much amount of time at a given interest rate? But this formula here, we could solve that for P. The student will observe that P would equal S divided by 1 plus R to the n. And the way we normally write that formula is P equals S 1 plus R to the negative n. Instead of dividing, we make it a negative n. Right. Next example. How much do you have? How much do you have to deposit now? So P is a present amount. P is a present amount. Right. So how much do you have to deposit now in order to have $1,000 in 5 years at 4 3/4% interest, with interest compounded monthly? So in this example, we have what? We have our S, our future amount that we want is $1,000. Right? R, now this is interesting. It says here 4.75 interest, that's an annual interest. Anytime it doesn't say, that's an annual interest, okay? So my annual interest is annual, I'm gonna call it APR, is what? 4.75. All right, and that's gonna be 0.0475. So to plug in my formula for part A, we have interest compounded monthly. Interest compounded monthly. So my R is going to be 0.0475 divided by 12. And so my P is going to be 1,000, which is my S, times 1 plus 0.0475 divided by 12 raised to the negative, now we're told 5 years. I didn't put that here. N is 5. N is 5. So this is minus 5.
Why don't you take that times the 12 too?
It's going to be, yes, yes, times. Trevor asked, why isn't that times 12? And it is, because this is the number of periods. Well, you can't, I know, Thomas can't see that. That's the number of periods, right? This is the periodic interest rate. Right? And this is the number of periods.
Say minus 5.
Yeah, it's a minus for this up here. Right? And so this is not, I should just say 5 years. That's part A. Oh, by the way, that equals, we didn't say what that equals. That equals, it's over there on the right, 788.97. I'm getting to the edge of my camera range. So I'm going to squeeze part B down here. Part B, we change the interest rate, or excuse me, the compounding frequency to daily. To daily. So P is 1,000. 1 plus 0.0475 divided by 365. That's a daily interest rate. This is a case where you absolutely don't want to be writing down intermediate values. Because if you round that, and you're going to be raising it to a really high power, if you round that interest rate and then raise it to a really high power, your error is going to go crazy. All right, so that's going to be to the minus 5 times 365. Okay. And that winds up being 783.35. Now, why did that amount come out less? You needed 788.97, basically 789, if you were compounding monthly. You only need 783 and change to get $1,000 in 5 years compounded daily. And the reason is daily has a higher effective interest rate because of this over here. When you compounded more frequently, the interest rate goes up. The effective interest rate goes up. So when we compounded from monthly to daily, the effective annual yield, annual interest rate goes up. It goes up. And so you don't have to deposit as much now at this higher effective interest rate. You don't have to deposit as much now in order to have the same amount in 5 years.
I still got 788.
For this? Yeah, you shouldn't. No, you shouldn't. Right here you say you got 788?
0.0475 divided by 365
Uh-huh.
Because
plus
it doesn't
1
make sense.
plus 1
Well, I've got the calculation over there on the right. It should.
negative 5. You sure it's a 8, not 3?
It's a 3. Right here, you mean? Let me see what let me see.
I got 788 also. I think it's a 3.
All right, hang on. 3. 1,000. 1 plus.
Because if you increase the n, your amount has to increase.
You are getting 788. Now what's happening?
So I got 2.
I'd believe you if I didn't have it right on the screen in front of me. The thing is too, we're getting 788.61, not 783. Oh, you know what? On the slide is wrong. I divide 0.475 by 355 instead of 365.
This one we have 788.609. On mine, I don't know why yours is different, but I have 788.6.
Oh, okay.
That's what I got too.
Okay. I have an older set here. Okay, good. Okay, this is good here. So we have a correction right here. And this is correct. Thank you for mentioning that. It's at 788.61. Yeah. I'm using an older set of slides. Evidently, I messed it up in class that time. Thank you, Trevor. All right. So now I'm going to go back over here. And we have homework 5.21 there. We'll make that due Wednesday. Okay. All right. We got enough due Monday. We'll make 5.21 due Wednesday. All right.
Mr. Ray, I have one question.
Yeah.
If your interest is like, if it's bigger, so if daily, your amount has to be bigger than it's monthly, no?
Well, if I understand you correctly, if the interest rate is compounded daily, you have a higher effective annual interest rate, and so you need a smaller amount to reach 1,000 because you have a faster, a higher interest rate. All right, now things get interesting. Things get interesting, and I'm going to actually erase all of this and see if we can get this done in 10 minutes. I don't know. We'll see. All right. Let's see if we can get this done in 10 minutes. Example. You owe $11,250 due in 10 years. So let's draw a little, it's an example. We're going to draw a timeline. Right? This is 0 years. And this is 10 years. Okay? In 10 years, that's the due date. So this is 11,250. All right. But we have interest. And we're going to pay it off in an interesting way here. We're going to do $1,000 now. I don't know why you would borrow money and pay back 1,000 of it now, but okay. It's an example. It's COVID. It's COVID, right? 2,250 you're going to do in 3 years. 3,500 in 6 years. And then you're going to pay it all off in 8 years. So we have the following here. We have 3 years. Let's do like right there for 3. 6 years. And here is 8 years. How much would the final payment be? So you're interested, you see what's happening here. Here you're gonna pay $2,250. 1,000 here, $2,250 here. $3,500 here. And then here you're going to pay the rest. How much is the rest? How much is that final payment? Now, here's our strategy. Do I have here? Yeah, I'm going to go with strategy. Strategy. We're going to construct what the present situation will look like in 8 years. Because right here is where you're paying everything off. So construct the present situation in 8 years. Okay. Now 5% interest apply, right? We're going to apply 5% interest, but this is how much you have due. So if I pay that off early, I have to pay off less, right? So any money I put in now is worth more there, okay? So how much would the final payment be? Now watch, here's what we're going to do. Let's do a real simple one. Here is going to be 1,000. This is 2,500. And this is 3,500. And this is the amount paid here is X. That's what we're looking for. X. How much is this 1,000 worth in 8 years? So what we're going to do is we're going to take this $1,000 and we're going to move it forward 8 years. So this $1,000 is paid 8 years early. It's paid 8 years early. Now it's compounded monthly. So the $1,000 is paid 8 years early, compounded monthly. How much is it worth in 8 years? So it's going to be $1,000. $1,000. 1 plus 0.05. Take care, Emily. Hope it didn't kill you. Hope you did well. Right. Divided by 12. And that's the periodic interest rate. How many periods are there? 8 times 12. Right? And I don't know how much that comes to, just keep that in mind, okay? Then, this amount here is paid 5 years early. This is paid 8 years early. So this one's paid 5 years early. And so it's going to be 2,500. 1 plus 0.05 divided by 12. 5 times 12.
Why? Just a quick question, but is it a negative 5?
No, this is going to be a negative over here. Let's talk about this one for a second. We still got one more to do here.
Well, I'm confused because like I tried to finish that calculation for 1,000 and it came out really big.
Yeah, it shouldn't come out that big.
Never mind. I messed up. I did. Never mind.
But like right here, for example, this one that's this 11,250. If I roll that back 2 years, that's going to be 11,250. 1 plus 0.05 divided by 12 to the negative 2 times 12. All right. So if I were going to pay this whole thing back in 8 years, this is how much I would owe in 8 years. This much. All right. And last, I have this here that's getting paid 2 years early. And that's going to be 3,500. Left parenthesis. 1 plus 0.05 divided by 12 to the 2 times 12 power. Okay, now get ready to do some writing. Okay. So what equation do we have? This is how much we owe. in 8 years. This is how much we're paying. So it's going to be 1,000. 1 plus 0.05 divided by, I'm not going to go over further. 1,000. 1 plus 0.05 divided by 12. 8 times 12. I'm paying that. Plus, I'm paying this 2,500. Plus, I'm paying this 3,500. Plus, I'm paying my final payment, X. Okay.
Brother, I have a question on how we got -2 on
The negative?
-2.
Right. That's because I need to know what this 11,250 is 2 years from now. In other words, how much do I have to have now to have 11,250 in 2 years?
Okay.
Right. And so that's going in the opposite direction. That's why that's negative. Mario's mentioning something important. All right. So as they say, solve for X. Yeah, right. So X is going to be, X is going to equal what? This amount minus all of these payments. And that comes out to $1,936.10. Now, first of all, let everyone's hand recover, because I know your hand is going like, ah. All right. Secondly, I will construct a set of notes for this. In other words, I might bring in what I did last semester, and I will post those notes for today as if we did them on the screen. All right. And so that may help, Tomas, to make sure you copied down everything right. So there's going to be notes for these slides today. I'll try to put those together this afternoon. All right. Please accept my sincerest thanks for how flexible you had to be today. If you have any questions, the learning is the most important part. But you guys were over the top accommodating, and especially Tomas over there. Sorry you had to do this. You're going to get some notes online. On Friday, tomorrow I'm gone for a school field trip. Pretty much the whole day. There's a science field trip I'm gone for. So I will be available earlier Friday or this afternoon if you want to come by for some help. All right. See ya.
Just a minute.
Yeah.
Can you help me quickly on a couple of problems?
Yeah. Just hang on a second. I'll make sure that. Did I start recording?
I think you did.